Okay, so this is 2.2 in your textbook, page 81. And what this is we're going to be using the tangent ratio to calculate lengths. Okay, so if we remember what the tangent ratio is, you should remember, let's make a straight line here, somewhat. If I have a right triangle, and remember the tangent ratio only applies here with the right triangles, that's a triangle that has a 90-degree angle, right? That's a right triangle. And if we're talking about one of the angles, let's just call this angle A here, the tangent ratio for A is the ratio of the opposite side, that's this side right here, divided by the length of the adjacent side right here. So you have this as an equation, right? Tan of A equals opposite over adjacent. Correct? Okay, you guys remember that, right? Opposite over adjacent. Okay, so in 2.1, we did a lot of questions calculating the angle measure using our second function here. So that's what we did here just in this previous example, tan to the -1, right? That just went away on me. Tan to the -1, solving for the angle. Now, in this section, we're doing a lot of calculation of lengths. So let's just say that in this, let's just use this diagram, and let's say we have, let's get rid of some of this stuff. Let's say I'm trying to find the height of this, and let's say this is a, what is this going to be? I don't know. Let's say this is a building. All right. So there's my building. It's my little, office windows. My little door. Okay. That's the height of a building. Let's say. And let's say that this angle right here. What would be the estimate for this angle? Any guesses? Just looking at that. What would you guess that angle to be? 35. Okay. I can live with that. Let's say that's 35 degrees. Good job. It's a good guess. Remember, 45 would be kind of halfway. Like if you can see the squares on this, that's 45. That's 90, right? So 35, great guess. Good job. Okay. So, and let's say that we are at a position here. This is us. We're laying on the ground for some unknown reason, and we're looking up at this building, at the top of this building, okay? We're right on the ground. Our eyes are right on the ground here, and we're looking up, and we know that the angle at which we are looking up, this is the angle of inclination. Let's talk about that. Angle of inclination. Yes, that is a strange English word. At the root of this word is the word incline. Okay, you see that? I-N-C-L-I-N-A-T-I-O-N. Angle of inclination. What that means is we have a horizontal line and we are going up from the horizontal line. So an inclination, it's like the angle at which, the slope is rising there. So 35 degrees. Do you guys know what this would be called? If we had a similar, you know what this right here, you know what this is called? Good guess. Not declination. No, declination. That's a good guess. But it's actually the angle of depression. Okay, so it's kind of depressed down there. So if you're feeling bad, you can say, I have a really high angle of depression today. Okay, so let's write that down. You can see that in your textbook, angle of depression. Now, it's this angle right here. Remember, everything is from the horizontal in these two situations, from the horizontal. This is not the angle of depression right here, because this is not from the horizontal here. This is not horizontal, and this is not horizontal. This is the horizontal right here. So, again, that's the angle of depression there. This is the angle of inclination. Okay, that's just a little aside. You'll see that in your textbook. Okay. Now, let's go to this. We're trying to find out how tall this building is. So let's say it's X meters. It's unknown. So we can set up a simple equation, and let's say, I didn't finish this here. We're laying on the ground. We're looking up at the top of the building. It's 35-degree angle of inclination, and we are 200 meters from the building. Okay? We know for a fact that we've measured this out, and we're 200 meters from the building. We can calculate the height of the building. And actually, we are going to do we're going to do like a math lab activity, and we're going to actually calculate heights of different things around the schoolyard. Flagpole, school, gym, all this sort of big tree, whatever. We're gonna do this, okay? So this is how you set it up. You go tan of A, which is 35 degrees, right? Because here's our pattern, right here. Tan of 35 degrees equals the opposite side length. Now this is unknown, so let's put our unknown variable there, just to say that this is unknown. This is what we're going to try and find. Divided by adjacent side, which is 200 meters. Okay, that's your first step. You just take the tangent equation, okay, and you fill in all the appropriate values. So our angle is 35. Boom. Our opposite side is unknown. Boom. The adjacent side, 200. Boom. You just plug them right in. Right? Easy. Now, how do we solve for x here? Any ideas? How do I find my unknown? Yes. You multiply everything by 200. Very good. Because this 200 is right here, it's in the denominator, right? So x is being divided by 200. So I need to multiply both sides by 200. What you do to one side of the equation, you have to do to the other side. And this is how we get rid of the 200. You see that? 200 on the top, 200 on the bottom. This really is 200 divided by 200 is 1. Right? So that's why the 200 is gone, because 200 over 200 is 1, and x times 1 is just x. Okay? But what do we have over here on this side? Well, now we have 200 times tan of 35. And this is no problem if you have a calculator. Okay? If you don't have a calculator, it'll take you a little bit longer. But, just an aside, back in the day, and now I grew up with calculators. Believe it or not, there were calculators existed. Yes, I know, when I was a small child. But I know that some people older than me, I'm not going to mention any other teachers' names in this building, but I know my teachers, they used to tell me, "Yo, just be thankful you got a calculator. We had to use the trig tables." And what it was is like literally pages and pages of like the tan ratios, like the actual numbers for every angle. And you had to look it up. Maybe get a copy of it sometime for you. But you had to look up, okay, 35. Okay, here's 35. Now go over. Okay, sine, cosine. Oh, tangent. Here we go, tan of 35. And you had to like write down the big long decimal number and use that. Okay? So just be thankful that your calculator is going to do it for you. And what I mean by that is, of course, this. Tan of 35. Well, then you couldn't do it. Or you had bigger tables, or you had like pages and pages of tables with like 35.1, 35.2, 35.3. If it was like a decimal, it was, 4 or 5 decimals. No, you're looking up the encyclopedia of, I don't know, trig ratios. I don't know if they even have those, but no, you couldn't do it then. So tan of 35, your calculator spits it out right there. There we go. That's the tan of 35. And you're going to multiply that by 200. So that times 200. So that's 200 times tan of 35 is 140.04. So x here equals 140.04. And of course, in the context of this problem, that's going to be in meters, right? Because this was 200 meters. So the height of the building is 140.04 meters. Okay? That is a really, really tall building. But notice what I've done here is I've written a word sentence because it is a word problem. All right? You didn't see the word problem here, but I gave you the word problem. I've read it out to you. So with a word problem, you should write your answer in word sentence at the end. Everyone hear that? Write it out, the answer in words at the end. Okay, so that's an example of calculating a height. And of course, we'll do an example where we're calculating the length as well next. Okay, question was, what does tan equal? I'm glad you asked that, because tan by itself means nothing. Okay? So let me just talk about this for a second. Okay? We have numbers like 5, 10, we have variables like x, 3x squared. Okay? we understand this to be a separate value, right? And this is a value. This is a value. This is a value, but it's 3 times x times x. Now, each of these pieces are separate. Even 10. 10 can be 5 times 2, right? Like, break it into pieces. But tan is not one of these. It's not. It means nothing on its own. The tangent simply, now this is going back to the definition of a tangent. The tangent always has to be attached to some angle. And what it means that for that angle, there is a ratio of the opposite side to the adjacent side. So you can't, if you have tan of 35 degrees, this is not tan times 35, okay? It's not like that. It's not like 3 times x times x. That's what this is. This is not tan times 35. This is all one unit. Okay, it's all one entity on its own. This is tangent of 35. Okay? So that's a very good question. That's a very common misconception. Even the grade 12s get that wrong sometimes. They're like, oh, I just need to divide by tan, and then I'll get 35 degrees all by itself. No, you cannot do that because it's not tan times 35. It's tan of 35. So the tan to the negative 1 is the only way that you can undo this, get rid of this tan part. Okay? Now, notice that it's not dividing by tan. This symbol looks like it might be like dividing, but we're not dividing. It's the inverse operation. It's not dividing. It's taking the inverse. So basically what this button on your calculator says is that, okay, if I have this ratio right here, this number right here, that is the tan of some angle. And this function on your calculator tells you what this angle is. Like, it's a special function. So it's not as simple as multiplying, dividing, subtracting, nothing like that. It's a function that is able to interpret this ratio and tell you what angle this is the tangent of. Okay? That's a good question. All right. So let's do another word problem here. Okay, write this out here. Okay. Let's say that I have this angle right here, and let's say this is 50 degrees. Okay. And here's the right angle right here. And I've got a length here of 55.2 centimeters. And I want to know, what this side is right here. Okay? So if you're given this, once again, you just go back to say, I know what I know. Tan of some angle equals opposite over hypotenuse. Oh, I'm getting ahead of myself. Sorry. You guys don't even know what you do know what a hypotenuse is. Over adjacent. It's just a different ratio. We'll come later. Opposite over adjacent. Okay. So you go back to this diagram and you say, okay, what do I have? Do I have A? Yes, I do. It's 50. So you go tan of 50 degrees. Okay. Do I have the opposite? I do. So 55.2. So you just put it in its spot. Do I have the adjacent? Well, no, that's what you're looking for. Okay? So you set up your equation just like that. All right? And I need you to set up your equation. I need you to show this step. Okay? Don't skip this step. As a matter of fact, you should be getting to the habit of writing out the tan ratio, statement here. You should get into a habit of writing this out. Okay? Come on. You should get into a habit of writing this out every time. It'll take you 1.75 seconds, approximately. So it's not a big deal. But this step for sure you need to show. Okay? Now, how do I get x by itself? Okay. X right now is in the denominator. Okay? In order to isolate for x, you need the variable in the numerator. That's not in the bottom of a fraction. That's up in the top somewhere. Okay? That's the numerator up top here. This is numerator. This is numerator. Right? The denominator here would be 1. Right? So x cannot stay down here. X has to come up. How do I get x out of the denominator here? Multiply both sides by x. Yes. So how does that work, Mr. Maxwell? Well, this x and this x are gone. They divide out. So on this side, what you have is 55.2. And on this side, you have x times tan of 50. Okay, I still don't have x by itself, Mr. Maxwell, so what do I do? Well, not too difficult. You just have to do one more step. If x is in the denominator, to get x by itself, you got to do 2 steps instead of 1. Anybody know how I might get x by itself here? Divide by tan of 50, because this is what you want to get rid of here. You want to get rid of this. What you do to one side, you have to do to the other. So x is going to equal here 55.2 divided by tan of 50. Then once you get to this point, you can just do that on your calculator and get an answer. So you type that into your calculator, you get an answer of 46.32, and that's going to be centimeters. So that's 46.32 centimeters. If it was a word problem, you would say the distance or whatever it is. If it's just a problem like this, you don't have to have a word sentence, so just circle your answer like that. Okay? In this activity right here that I'd like you to do, I want you to create a right angle triangle. So a right triangle with your ruler. If you have graph paper, you can go ahead and use the lines on your graph paper. Okay? But you create one of any size, any shape on your paper. Okay? So I'm going to make a right angle triangle here. Okay, so you create a right angle triangle. This is a 90-degree angle because I've lined it up with the lines on my paper here. What you need to do, take your ruler and measure, right? Start at 0, measure the length of this side, right here, and label it. Label, you measure centimeters. Do the same thing for this long side and this side. Actually, you don't have to do the long side even. Do the same thing over here, label it. With your protractor, measure each angle. With your protractor, measure each angle. Okay, so this protractor right here, this is a bit different than yours, but really what you're doing is is it frozen? Thank you. This is a different protractor than yours, but you have half the protractor. What you need to do is line up the vertex here, right in the very center, and the horizontal line right along the 0. Okay, and then you look at where the other line comes up, and you look at the angle here. So if we keep playing this through, see this is an angle of 110 because it's lined up right with 110. This one is 90 right there, you see? So you use your protractor to measure the angle. So watch this. The protractor is going to slide up into place so that this crosshair right here is at the vertex. You see that? And this line is right along the 0 degrees here. Now you're obviously going to start from 0 and you're going to count up. What's the measure of this angle right here? Using the protractor there, what's the measure of that angle? Anybody? Okay. I've heard 2 answers, 45 and 145. Or 135. 145 is nowhere near. But anyways, please watch this. This angle is less than 90. It is an acute angle. It cannot be 135 degrees. Okay? Look at this 135. If you look at these numbers, that's counting all the way back from 0 here. Okay? So what you have to do is you have to start at the 0 here, because this is the horizontal line, and you count up 10, 20, 30, 40, and you look up here, see there, this is 40 right there. 1, 2, 3, 4, 5. That's 45 degrees. This is a 45-degree angle. That's how you measure that in your protractor. Okay? All right. So, okay. Okay, going back to here, so measure both of these angles, that one down there and this one over here, okay? Measure both of those angles. And what I want you to do is I want you to confirm that this tangent ratio actually works with your triangle. And do it multiple times with both of these angles, okay? And you can even use it to find a missing side even though you know both of these sides. So just set it up. Okay, measure your angle and your side lengths and set up your tangent ratio and confirm that the left side is equal to the right side. Okay, so if you had a diagram here, a triangle that you drew like this, and this isn't to scale, obviously, because I'm using someone else's data, but this is the data so far. Okay, so what was the measure of this vertical side here? 3.2 centimeters, okay, and what about this one? 5.1. All right, so now again, here's the point to this activity, okay? Each of you should have a triangle that's slightly different than this one, right? Different angles, different lengths of sides, okay? The chances that we have two exactly the same triangles, unless you all copied your triangle, you know, measuring stick there, whatever, the chances that they're the same, very, very slim. So what I want you to do is I want you to test this known right triangle right here. I want you to test the ratio to see if it works. So for example, tan of 57 degrees, according to this diagram, should equal what? 5.1, that's the opposite side, divided by 3.2. So you get on your calculator and you test this out. What is tan of 57? Well, tan 57. That is 1.5399. 5399. Okay? And what is 5.1 divided by 3.2? Look at that, 1.59375. 1.59375. Now, these numbers should be pretty close. Okay? Obviously, we're limited because we're rounding to the nearest degree here. If you went 57, if you were a little more precise, maybe these numbers would be a little bit more closer. But do you see what I'm saying? This tangent ratio should work with known measurements of a right triangle. It should work. So how many of you have done this with the data from your triangle and you've come up with a number that's pretty close on both sides of the equal sign? Okay? Anyone done okay, that's a lot of the class. Anyone done that where it's totally opposite and you've checked it over and it's very different? Okay? So I want you to do another calculation using 33 or using your other angle and confirm. So I want you to do this one more time for this activity just to see if you can get this number to be the same again when you confirm that. So just go ahead and finish off that activity by doing tan of 33 here. In this case would be 3.2 over 5.1. Make sure those are the same as well. Okay, so let's do this question. It says Amanda is outside flying her kite. She knows that the string of her kite is 50 feet long. She measures its angle of elevation as 32 degrees. For the following questions, assume the string is straight and ignore Amanda's height. So, first one, draw a diagram to fit this word problem. All right, let's just say, and this is what I'm thinking, if it's oriented different, that's fine. Here's Amanda holding the kite. The string to the kite is 50 feet long, okay? Okay, here's a little kite, right? 50 feet. The angle of inclination is 32 degrees. So this should be your angle of inclination. If we were to draw a diagram that represented this, let's make sure that we've closed this off as a right triangle. And that's the sort of diagram that you should write to go along with this word problem. Okay? All right. Now, if yours is positioned the other way, if you've got 50 here, if you've got 32 here, and whatever, your kite here, I don't care. I don't care if it goes the other way. It doesn't matter. All right, so B says, calculate how far above the ground Amanda's kite is. Now, we're ignoring Amanda's height, so really what I'm after here, and we'll factor in Amanda's height here in a minute. But what I'm looking for here is this length right here, from here to here. That's what I'm looking for. Okay? So why don't you take a minute, solve what that height is right there. Solve for x. Go ahead. And I'll show you my answer in a second. Okay, so I do have to give you one more piece of information here because this can be solved but not using the tan ratio. So this question, actually, the way it's given, you need a different trigonometric ratio, which is coming in the next section. So I will give you what you need here. You need the fact that this is going to be 46 feet on the bottom. Okay? This is going to be 46 feet. Now you can use the tan ratio. Okay, knowing that. Yeah, I'll give you that this is 46. And we'll ignore this for now. Yeah? The kite is 28.7 feet high. Okay, for A. So again, your tan ratio here, opposite side is x, adjacent side is 46. Okay, please show your work like this. Don't skip any steps. That's B. Here's A over here. Okay. All right. I'm going to give you some questions to work on here for the last little bit. And again, this is 2.2 in your text. Okay, calculating lengths.